This lecture is about load determination, which covers aspects of variations in demand, the effects of those variations in demand, customer tariffs, and also electrical billing. So let's start with load determination. Load on a power station usually varies due to the uncertain demands of consumers. The effects of that load will be that the power station would generate power irregularly. You need also power generation regulation equipment, and there will be poor efficiency. But in the real sense, your demand will never be flat. That is, throughout the course of a day, the demand from, say, midnight to 6 to noon to 6 p.m. to midnight again, let's chart that out, generally will follow a path that looks something like this. In most cases, this is what the loads of consumption will look like. So load determination helps us to take into consideration all the various variations that take place and account for them. And also it enables us to look at the most efficient way when we are doing power station sizing and regulation. So some of the common terms that we use are, number one, connected load. So this is the total rated capacity of the load that is tapped from the power station or from the power sources that are given. Second, we have maximum demand. And maximum demand is the greatest demand during a given period. For example, demand KVA. So in the case of our graph here, the greatest demand would be at the peak as indicated there. So the maximum demand is the greatest demand during a given period. Third, we have demand factor. Now, demand factor is the ratio between the maximum demand and the total rated capacity that you would have, or the total connected load. It is the ratio between the first two. The fourth is average load. And average load provides a weighted average of the consumption over a given period of time. So it's total consumption in terms of energy over the area, the hours in that period. Next, we have load factor, which is different from demand factor. So our load factor is the average load over the maximum demand. This determines the cost per unit of running that station. And finally, we have diversity factor. And the diversity factor is the sum of individual maximum demands over the maximum demand on the power station. This will become a bit more clear once we do an example. So to make this clear, let's look at what each of these means through an example. So a consumer has that load schedule for the day. It looks similar to what we had seen here, with a rise in the morning, steady through the day, and a peak in the evening. Or, similar to that during the day. This seems to be more of an industrial customer, the higher load during the day. So now, if the tariff is 50 cents per kilowatt of maximum demand, 35 cents per kilowatt hour, what is the daily bill paid? So in order for us to determine the load factor, which is one of the items that we have been asked for, so load factor is the average load over maximum demand. So let's determine each of those. So the average power, which is the average load, is given by the total energy consumed over the time. So in this case, we would list all of the energies that are here. So in the case of here, so it would be from midnight to 6, we have 200 times 6, which is 1200. From 6 to noon, we have 3000, and it is a period of 6 hours, so it is times 6, which is 18,000. From noon to 1 p.m., that's 1 hour, it's 100 watts. So the total energy is the energy over each individual time period. Yeah, the power times the time. That's 100. 1 to 4 is 4,000 times the period itself is 3 hours, which is 12,000. And you have 4 to 9 is 2,000 times, it's a period of 5 hours. It is 10,000. And finally 9 to 12 is 1,000 watts over a period of 3 hours, which is 3,000 watts. Okay, the total for that, let's get in the calculator. So the total for that is 1200 plus 18,000 plus 100 plus 12,000 plus 10,000 plus 3,000. That's 44,300 kilowatt hours. Oh, sorry, watt hours. So we divide it by 1,000 to get the kilowatt hours. So this is just watt hours. So that was the average load. Now to get the average power, we would do average we would do 44,300 divided by the time period, which is 24 hours. That is given by that is 100 or 1,845.83 watts. That's your average power over the entire period. You cannot just divide all 6 of them because they are over different periods of time. So you have to get the total energy over the total time in order for you to get the average power. So your load factor, which is average load over maximum demand, will be, our average load is at 184,845.83 divided by your maximum demand, which is 4,000. That's your maximum peak that you have gotten, over 4,000. So again, that gives us 46.1%. So your load factor is you're using 46%. What this means is that on average, you're using 46% of the actual capacity that you have, right? Assuming that your maximum load is 4,000 watts. Generally, over the course of the day, you'll use 46% of that on a weighted average. In addition to that, the maximum demand charge. So now let's look at the tariffs. So your tariff. And the bill. So the bill was being charged. You have a certain fee per kilowatt of maximum demand and a certain fee per energy. This is a common way of charging. So your fee for maximum demand. The maximum demand was 4,000 watts. So let's convert it to kilowatts. So 4 kilowatts, you divide by 1,000 times the charge is 50 cents. So 0.5. That gives you 2 shillings. And your kilowatt hours charge, which is the charge for the actual amount of energy consumed, is the total energy consumed was that 44,300 divided by 1,000 to get kilowatts times 35 cents per kilowatt hour. So 0.35. And that will give us 44.3 times 0.35 is that 15.5. Let's call it 0. So your total daily bill will be the sum of these, which will give us 17 shillings and 50 cents. Right? That's the average bill. And this is common for a lot of tariffs that are charged, which we will see a bit later, the next section, which is about billing. Let's look at another example. So a second example, we have that generating station that provides supplies different loads, and we need to look for the units generated in a year and also the diversity factor. So diversity factor is the sum of individual demands over the maximum demand. So let's have a look at that. So first of all, what's our load factor? Load factor is given by average power over the maximum demand. And in this case, it is 0.305, 30.5%. We don't know the average power, but we do know the maximum demand is 18,000 kilowatts. And we're looking for average power. So rearranging is equal to 18,000 times 0.305. 18,000 times 0.305. So our average power is 5,490 kilowatts. Right. Now, based on that, what is our total energy as well? So total energy is equal to 5490. So this is the average power, and we are looking at the generated units within a year. So we'll do 5490 times, there are 365 days in a year, times 24 hours in a day. That will give us the number of kilowatt hours that we will have consumed. So that is 48, let's put it in a different form, 48.09 times 10 to the power 6 kilowatt hours. Okay, and this is your number of units generated in a year. So start with annual units. And below here we have diversity. Factor. Okay, so diversity factor, we said sum of individual demands over maximum power demand. So sum of demand is the sum of all the demands that we have here. So just sum them up. Then 500 plus 5,000 plus 3,400 plus 4600 plus 2800. So that is 23,300 is equals to 23,300 watts. Divided by your maximum power demand, which we have already seen is 18,000. So your diversity factor equals 23,300 divided by 18,000. That gives us 1.294. So that's a factor over which we are diversifying.